Here we go. Okay, so adding data, the basics of this. So this is what, when you double click that, when you've downloaded QGIS and you've got that icon on your desktop, ideally, or if you go to it from your start menu and you click on it, this is what you get. Don't freak out. GISs are enormous software builds. So there are hundreds of buttons, tools, options, etc. 95% of them or more you'll never need, because again, pretty much all disciplines or many disciplines use GIS. Many areas of industry use GIS. So you have people who are more involved in transportation or transportation engineering, sewer networks, water management, geology, climatology, meteorology, public health, clinical medicine, where we are, aviation, et cetera, et cetera, et cetera, earthquake engineering. They all use GIS. As you might imagine, a lot of what they're doing, excuse me, technically is going to be different from what you do. And so there's some specialized tools that are going to be really specific to different people. Habitat management, wildlife biology management, all of them, they all have their own tools. So don't feel panicked when you see all of this going on up here and all of this going on down here. You won't need most of it, okay? It's just there for all the many people who use GIS. Okay, so this is what it looks like. When you want to add data, and in GIS speak, there are layers. So think about it, going back to our last meeting last week, and there was that graphic of kind of all the different layers that can be stacked on top of each other in a GIS, and how that really is kind of the defining power of a GIS, is that you can bring in any layers as disparate as you want, ranging from, microbiological data to social drivers data to atmospheric data. They stack up in place, which allows for us to then, for our purposes, link that to a patient in there, to like a patient address, for example, and we can then model out all of these different variables, and these complex relationships that actually produce human health. So it's very powerful that way, but it really all starts with this little button here. And this is the add layer button, okay? Now, when you click on that, again, you're gonna see a lot of different types of data you could add. Most of them you will never use in clinical medicine. What you will use, at least in the early days with me, is what's called vector data. The other one we might play with a little bit. We'll see where your interests go. The other type we would use is what's called raster data, that's down here, but we will not be touching any of the rest. So don't even look at it. So vector data is discrete data. It's those shapes you see. It's points and lines and polygons. When you look on it, look at some of the maps that y'all used as part of your introductions to yourself. If you look at like a distribution of a disease as points, cases on a map, those points are a discrete object, so it's vector data. When you look at road networks, those lines are those are discrete segments and features, also vector. When we look at the data we're using today, it's going to be all polygon data, so states and counties and places and census tracts, which are that proxy for neighborhoods. Those are all polygon shapes. They're discrete. They are vector data. So a lot of health data and social drivers data and administrative data, like our boundaries, political boundaries, that's all vector data. Raster is continuous data, and that usually is some form of environmental data. So if you think about today, which in the news, all of the heat waves going through the country. So temperature, it's a continuous variable, it's continuous data. It's usually represented as little grid cells. The whole world or the country gets divided into little grid cells. Each one of those little grid cells has a value for the temperature in that location. And then so it's that grid cell rasterized view that we use in a geographic information system. So you can see you've got points and lines here on the vector icon, and you've got these little squares, which are grid cells on the raster icon. So that's what you'll primarily be using. And again, for us starting out, it's going to be vector data right here. So and again, don't look at all of this. The default is fine for file. The encoding is automatic. This default's fine. What you're going to do is you're going to click on this little box down here with the dot, dot, dot. And what you're going to do is browse to the location where you have your geospatial data. Now, recall back just a moment ago, in Google Drive, we had our GIS data. And if we start with the first layer, the largest layer that we're going to look at, the largest scale, the most core scale, it's the US states, and this is from Census 2020. When you go into this folder, you're going to see weird naming. That's really common with geospatial data. You'll get used to it. It does make sense. It's just, it doesn't make sense at the beginning. So this is from the National Historical Geographic Information System, 0086 shape. This is the state shape file or layer files. When you unzip this was all zipped up in Google Drive, and when I downloaded it and extracted it or unzipped it, these are all those files I was talking about. They have the same name, but a different file, because each one of them plays a different supporting part in making the GIS run, making the data run. So the one that you are going to want to add to QGIS is this one, .shp. Don't be confused by this .shp, which is actually a different sort of file. Normally your .shp file, your shape file, is going to be, if you look at the file sizes, it is by far the largest. Okay, that should give you your clue that that's the one you need to add. Some of these others, they like the .prj, that's the projection, so the spatial reference, so where is it placed in space. The .dbf, that's your database file. So that's all of the data. So for example, if we were adding, like if we had population data by state, that population data would be stored in this DBF, for example. Okay, so there's a bunch of other files. They all have to stay together all the time. They all have to be in the same folder all the time, or the data won't show up in a GIS, which again is why we use the zip format to move the data around so we don't miss anything. Okay, so again, you're going to hit ... You're going to browse to wherever you've downloaded and extracted or unzipped the data from Google Drive, whatever folder you're using on your computer. You're going to just click once to select the .shp, again, usually the largest, and you're just going to say open. Now, again, you're going to get a bunch of other options here. You don't need to touch any of them. Don't even look at them. Okay, the default is just fine. And then you say add. And when you do that, now you've got your first layer in a GIS. Okay, so we have all of the states of the United States here. Okay, GISs are relatively steep, or pretty stupid. They are actually very stupid. You have to tell them the way you want to see everything. So it'll just pop stuff into the map. In my case, it kept popping up over in the lower right-hand corner. I don't know why, but it did. But it's all of this is easy to fix. So if you right-click on your layer over here, in this into the center of your view, okay? So you can easily see it, okay? I'm going to stop my video to just save my bandwidth. Okay, so now what I did is I repeated the same process. So I added this to the view. Then I went back up here to add data. I went back to what I downloaded from the Google Drive, and I wanted to look at counties. So I downloaded the county data, I extracted it, I connected here just as before, and now I've got the county data on top. But notice how a GIS is like a layer cake. Okay, whatever comes in on top is going to cover what's below. Don't panic. Your data did not disappear. Okay, it's just covered up. So you actually have a lot of flexibility over here to drag layers up and down. You can also, and I'll show you in a second, when you click on one of these little icons, you can change it. Is it filled or is it transparent? You can change the fill color, you can change the outline color, and you usually, the more layers you add, the more creative you have to get over here in terms of how you visualize the data, because of course it can get busy and stack up on top of each other. So now I've got counties. And then, so here's just the example of dragging. So I dragged, so states are on top. I clicked on that icon and I wanted it to be see-through, and I made the outline blue. And so you can see that that changed over here. So you can see your states and you can see our counties underneath that. Okay. And then what I like to do too is, and we're going to get into like querying our data so that we're just looking at Georgia and we're not using the entire United States. But just for our purposes today, we're going to get comfortable using these little navigation tools from about here to here. The hand, you can click on the map and pick it up and drag it around. But here, the magnifying glass, if you draw a box like I did just around Georgia, it'll just pop in to Georgia. So you're not, you've got a better view. You're not looking at the entire United States here. So now that we're zoomed in on our location of interest, I'm going to go back and add some other data. So again, I went here to this add data button and I chose vector data. This time I added census tracts, which again, for research purposes, it's considered a proxy for a neighborhood. So when we're looking at a lot of the social drivers of health data, we're often looking at it at the census tract level. So this is the unit of analysis, and you can see it gets pretty granular and grainy, especially like around Atlanta. And then when you go into any of the cities, Augusta, Savannah, Macon, Columbia, any of the cities, it's gonna get more difficult to see out here. And that's because census tracts are based on population. So and this is another reason why it's a popular geographic unit for research, is that the U.S. Census Bureau tries to keep them somewhere between 4,000 and 8,000 people, and they define them, they delineate the area, trying to create as much homogeneity as possible in the population. So it makes sense then that when you get into like Atlanta, you don't have to go very far before you hit 4,000 people. Whereas when you get further out here, like maybe you're down in like Harris County and Pine Mountain, you have to go a much larger area to hit that 4,000 minimum. So the size of census tracts changes considerably depending on where you are in that kind of urban-rural continuum. Okay, so that's why you see it the way you see it. Okay, so then the last data layer I'm adding that I'm having y'all play with at this kind of intro stage is places. So again, the same thing, I'm adding data, it's vector, I've downloaded it, I've unzipped it, I've selected the .shp file, and this is what we have here. So places are really a proxy for cities. Not always, but it's more just incorporated places. So you can clearly see up here in Atlanta, a number of cities, but you can also see as you move throughout, there are a lot more like just incorporated places. Some of these are a little different. So for example, my home, if we look at Muskogee County, the county and the city are consolidated. So for census purposes, the county is the city. The boundaries are the same, but that's not true in all places for sure. So now you're able to actually go in, and what I was hoping that you'll be able to do is go in and just kind of like investigate Georgia a little bit, especially your areas of interest, to figure out like, okay, what are the counties that I'm interested in? What are the cities, the places? What are the census tracts? What does it look like geographically? Because it's, as you can probably already imagine, as you're working in more rural places, the data becomes more coarse. The geographic unit of analysis, they're just bigger. So you can't get down into some of these very, very micro granular kind of scales because you just don't have the same population. So how do your places of interest look? Geographically, how might that affect your the way you map your data, analyze your data, make sense of your data, etc. Okay. Then the other thing I just wanted to show you is that if you click on any of these layers, right click, because you want to know what you're looking at, there's a show labels option. So I did that for the places, and obviously it's a mess when you're zoomed out to this level, but that's where you can just zoom in, right? And now we can see, okay, we see where Catala, Ellerslie, Waverly Hall, Columbus, and Muskogee County are the same thing, et cetera, et cetera, et cetera. So you can go in and actually check in with where you are, right, and what you're looking at. When you're happy with, well, and then here are those navigation tools. So the hand, again, to pick up and move. You can recenter the map, the zoom in, the zoom out, and then this is the biggie, right here, and I really should just like double circle, triple circle this one. This is the oops, I zoomed in wrong. And you can zoom in so far that you're lost in your map and you don't know where you are. This happens all the time. So it happens to me too. So this is the undo button for your zooming. So know this one well. I'm sure you'll get to know it. But that fixes whatever your problem is. The other kind of quick tip is that if you do zoom in a way where you don't know where you are, you can just go back over to the call. If you go over to your layers and right click on a layer, that first option is zoom to layer and it'll pop you straight back out. Now in this case, it'll pop you straight back out to the United States, but still it's a place for you to restart and kind of begin again with your investigation. So those are some things that commonly happen and quick fixes to that. When you are at a point where you're like, yep, I'm good for today. So GIS projects are not normally done in a day or even a few days. They're usually many, many weeks to months. And so we use a project format to save our work, because every day you'll do something incremental, or every week you'll do something incremental to move you forward. So when you're happy with what you've got, you'll click Save As, put it in a location, ideally the same location where you're storing all of your GIS data, and it's going to give it a name that makes sense to you. And it's going to give you this QGIS project format. So these are the kind of file extensions you'll see, and hit save. Okay. And then when you do that, you're all done. Okay. So you should stop sharing. You should be able to then come back to it when you open your computer. When you come back to it the next day or the next week, you should just double click on that project, or if you go to OpenQGIS, that project will be saved as your most recent. Click on that and everything should just open back up for you exactly as you left it. That a project does not save your data. Okay, a project file is a directory that tells the GIS, oh, she used the county data from this folder, she used the state data from this folder, she used the census tract data from this folder, eventually we'll get to the point, she used the patient data from this folder, she used the clinic data from this folder. It is a directory. It's like a table of contents that says to the GIS, go and pull all of these layers from these different locations to create the project that we had. So if you move even one little thing or rename one little thing, you will crash that component of your project. So it is very worthwhile for you to take 5 minutes, 10 minutes, 30 minutes, an hour, whatever it takes you before you get started, to say, okay, on my C drive, for example, and I'm a big fan of using the C drive because it's really hard to get lost in your C drive. C drive, and then one folder that's called GIS, right? And then everything you do, all your data gets stored there, all your projects get stored there, et cetera, et cetera, et cetera. That is a very quick, direct path, and you just don't touch it, okay? You don't move things around. Also, from a backup perspective, I think I talked about backups last week a little bit. When you're done with whatever you're doing, you can always just upload that entire GIS folder into a Google Drive or whatever your favorite cloud-based storage is. And so it's there, right? Or you can just copy it across to an external hard drive, or however you prefer to do it. It just really simplifies the entire like making duplicates process. Because sometimes you'll find, especially in the early days, and even now, and I've been doing this for a really long time, you'll get a ways down the road and some analysis, and you'll be like, that's not really what I want to do. Like, I actually think I want to go back a couple of steps and try something different. Then you always know you've got that data updated from 2 days ago or whatever it was, 2 weeks ago. So I'm a fan of uploading, and when you upload, don't overwrite the existing data that's there. Create just like a new, like if you were going to do this into Google Drive, I would, and I did my work today, I would just like zip up that GIS file and upload it to Google Drive and call it, GIS backup 0625 2025. And then maybe next week when I come back to it, I'll do the same thing, but I'll give it next Wednesday's date. And so now I have like basically a kind of a timeline of my data, which can be very helpful when you start to embark on larger research projects. It's just a way to prevent you from being in tears at some point and pulling your hair out. So that's kind of just a word to the wise, because I have been in those tears and pulled my hair out from some of those mistakes. So just don't do it if you don't have to. Okay, so I want to stop here. This is actually, I kept to time today. I wanted to stop at about halfway through so I can just let you work and just practice on your own. Now, if you are not in a place where that makes sense for you, or time, or you don't have the bandwidth, that's fine too. You can always come back to it at a more convenient spot, because of course it's recorded. But I am going to go ahead and I'm going to create some breakout rooms. And I'm going to let y'all choose. So here's the thing. You can either work and stay in the main room with me. You can go off in a Zoom room by yourself if that's your preference. Or if some of you want to work together in a small group, go over into a Zoom room and work together. Okay, I'm fine with all of it. I'm fine. It's such a small group that I'm also fine if you all just want to like stay here and like help each other out and talk through things. I'm happy for that as well. It's completely your choice. Okay, so that's going to be the next 30 minutes. Do with it what you want. And whenever you're ready to drop off and come back to the recording as needed. So it's good to see y'all, and I hope this helps. This is kind of a big deal, starting to get into your first GIS. And it's a little bumpy at first, but I promise you, once you get used to this, like next week, we're going to start adding some patient data and clinic, not real patient data, but synthetic patient data. We're going to add some clinic data. Then the next week after that, we're going to add a lot of the social and environmental drivers data, and we're going to start linking them. Okay, so then you're going to be starting able to make maps of like, oh, I've got clusters of patients with this outcome here, but not over here. So the analysis, the making sense of it. And for those of you who are kind of statsy, biostatsy in nature, you can put together a lot of variables that then can go into your modeling to look at what's driving some of these patient outcomes and maybe how and where should we intervene. So that's the path we're on. Okay, I'm going to be quiet. I'm here if you need me. You can reach me, just shout out if you need me, or feel free to put something in the chat. I'll monitor that as well. Okay? Okay, thanks. And in case you drop off before I talk to you, it was good to see you. And I'll see you next week.